Welcome to the DIY Honda Garage channel. The DTC P0113 relates to the intake air temperature IAT sensor 1, indicating that the sensor's output voltage is higher than a specified value. This can signal an electrical problem or failure within the circuit. The IAT sensor measures the temperature of the air entering the engine, providing vital data for the powertrain control module, PCM, to adjust fuel injection and ignition timing for optimal performance. Specifically, the IAT sensor is located near the mass airflow MAF sensor in the air intake system of the Honda CR-V. A malfunctioning IAT can lead to improper air-fuel mixture and significantly affect engine performance, fuel efficiency, and emissions. When the PCM detects this high voltage issue, it registers the DTC to alert the technician of an underlying problem that needs addressing. DTC P0113 is triggered when the IAT sensor 1's voltage exceeds a threshold of 4.92 volts, indicating that either the sensor itself or its connections are malfunctioning. The powertrain control module, or PCM, monitors this signal to ensure proper engine operation. The IAT sensor helps the PCM adjust the fuel mixture according to the air temperature, thus playing a crucial role in performance and emissions control. If the sensor's voltage is too high, it suggests a short circuit or other electrical faults rather than a simple sensor issue. This high voltage could potentially mislead the PCM into overcompensating fuel delivery. Frequent inspections of the IAT sensor and its wiring are advised to maintain optimal performance. Several factors can contribute to the triggering of DTC P0113. A faulty IAT sensor is often the most common cause, where it may be internally damaged or malfunctioning. An open circuit in the wiring, especially within the MAF sensor/IAT sensor 1 connector, can also produce high voltage readings. Another potential issue lies within the PCM itself. If it isn't processing sensor data correctly, it may register incorrect voltage outputs. Poor connections, corrosion at the terminals, or damaged wires can lead to problematic readings that misinform the PCM. Effective troubleshooting requires a comprehensive check of the IAT sensor, related circuits, and the PCM for correct function and integrity. Identifying the symptoms associated with DTC P0113 is crucial for efficient diagnosis. Drivers may notice poor engine performance characterized by sluggish acceleration or unresponsiveness. Another significant symptom could be decreased fuel efficiency, as the engine may run excessively rich due to incorrect air-fuel ratio measurements. Additionally, engine misfires might occur as the air intake readings fail to align with actual conditions. Other symptoms may include illumination of the check engine light and potential altitude changes affecting the vehicle's engine operations. Recognizing these symptoms early can enable quicker diagnostics to mitigate further vehicle damage. The first troubleshooting step for DTC P0113 involves ensuring the vehicle is in the on mode, allowing electronic modules to prepare for diagnosis. Utilize the Honda Diagnostics System, known as HDS, to check the IAT sensor 1 voltage output. This diagnostic tool provides real-time data and can indicate if the voltage exceeds the specified value of 4.92 volts. If this high voltage reading is confirmed, the failure is essentially duplicated, affirming the need for further inspection of the electrical components related to the IAT sensor. It is essential to conduct this test accurately, to decide whether the problem lies with the sensor itself or other components in the system. After confirming the high voltage from the IAT sensor, the next step involves inspecting the MAF sensor, or IAT sensor 1, and its connectors for any visible damage. Special attention should be given to the jumper wire setup. Connecting terminals number 2 and number 4 assists in helping check the continuity and ensures an accurate diagnosis of the sensor's output. Again, using the HDS, check the voltage output while the terminals are jumpered. If the IAT sensor 1 voltage remains above 4.92 volts, it strongly suggests a malfunction within the sensor itself. Alternatively, if the output is normal, this indicates an issue down the line, connected to the wiring or the PCM. At this stage, with the MAF sensor or IAT sensor 1 still disconnected, attention shifts to the external circuit, specifically the wires leading to it. Before proceeding with this step, it's advised to jump the SCS line with HDS to prevent errors while inspecting. The purpose of this inspection is to ascertain if there's an open circuit on ITA1, the signal, and SG2, ground. Utilizing an ohmmeter, verify that the resistance between terminals is less than 1 ohm when off, indicating a solid circuit with no interruptions. If resistance exceeds this threshold, it indicates a damaged wire or poor connection leading to high voltage readings. This critical step isolates potential wiring issues which may be contributing to DTC P0113. The final step in troubleshooting DTC P0113 involves a comprehensive inspection of the powertrain control module, or PCM, after confirming normal conditions for the other components. Focus on ensuring its connections are secure and check for any signs of faults within its operation. If previous checks showed normal readings, yet the high voltage DTC persists, it points towards potential issues within the PCM itself. Testing the PCM can be complex, requiring specialized diagnostic equipment, and any anomaly found here suggests replacement, as this module orchestrates several functions within your Honda CR-V. Addressing any faults is vital for restoring proper operation. After completing all necessary repairs and component checks, clear the DTC codes using the HDS. This step resets the vehicle system, allowing it to start from a clean slate. Following this, take the Honda CR-V for a test drive to ensure that the issue has been resolved and that the previously triggered DTC does not reappear. Monitor relevant performance indicators that align with the IAT sensor's functionality to confirm that the air-fuel ratio and engine outputs are functioning optimally post-repair. If the DTC reoccurs, you may need to revisit the inspection process to find any overlooked aspects. To prevent the recurrence of DTC P0113, it is advisable to perform regular maintenance checks on the IAT sensor and its wiring. Keeping the sensor and its connections clean and corrosion-free greatly enhances longevity and functionality. Inspecting wiring for wear and tear will help prevent intermittent faults that may lead to high-voltage issues. Regular diagnostics using the HDS can identify potential issues early before becoming critical. Additionally, replacing the IAT sensor based on manufacturer-recommended intervals or mileage may also help ensure proper functionality. Proactive maintenance not only improves performance, but also extends the service life of the entire engine management system. In summary, understanding DTC P0113 is essential for anyone working on the Honda CR-V. This code signals a high-voltage issue from the IAT sensor, crucial for maintaining optimal engine performance and emissions. The diagnostic process involves thorough evaluations of the MAF IAT sensor, its external circuit, and the PCM. Each step taken is integral in isolating the specific cause behind the DTC. Implementing regular maintenance practices ensures that these systems remain optimal and prevents future issues, contributing to the overall longevity of the vehicle. As a technician, Careful scrutiny and comprehensive troubleshooting will lead to effective resolutions and informed decisions moving forward. Please like and subscribe to the channel. See you next time.